Right now, I've had some questions about problem 5 on Set Theory 2 worksheet. That is, you want to determine I guess that's an n, right? N equals 1. You want to determine what that is. All right, so the answer is going to be, I'm not going to tell you exactly what it is. It's going to be some number, some integer, z, right? So the answer is going to be something like, I don't know, like say 50z. 50z. But it's not going to be 50z. So there's one out of infinitely many choices that you can eliminate. Haha. But let me give you some hints of like how to get going on it. All right, so what you need to do is figure out what this thing looks like. Okay. So first thing I would do is just write this out. So this is 1z intersect 2z intersect 3z intersect 4z intersect 5z. Okay. So it's an intersection of 5 different sets, and you want to figure out what this is going to be equal to some number like 50z or something, but it's not going to be 50, it's something else. So you need to figure out what that is. The way I would go about doing this, let's see, let's look at 1z first. I'm going to write it like this. So I'm going to write out some elements of 1z. Okay, what is 1z? All right, remember that nz is the set of all k times n such that k is an integer. So it's multiples. 2z is the multiples of 2, otherwise known as the evens. 3z is the multiples of 3. 1z is the multiples of 1, right? So if you put a 1 here, well, that's just k, such that k is in z. Well, that's just z. That's just the integers. So 1z is the integers. All right, let me write out some of these. Let's say 0, 1, 2, 3, 4, -1, -2, -3, -4, and so on. Run out of room for the ... but that's okay. Two z is the evens. So let's see, let's go -6, -4, -2, 0, 2, 4, 6, ... All right, so then 1z intersected with 2z is what they have in common, right? It's what they have in common. What's common to both sets? So the evens, obviously, right? So the evens. So this is -6, -4, -2, 0, 2, 4, 6. Remember, 0 is even. Right? So this is actually equal just to 2z. All right, so what we found here is that now you can do these in any order you want because intersection is commutative and associative. So we did this. So then now we have just 2z. So I'll do this part for you again. Okay, so 3z, right? So now what we're looking at is we're looking at this part. Look at this part here. Let's see, 2z and 3z. Okay, first 3z. Let's see, that's going to be multiples of 3. So you got -9, -6, -3, 0, 3, 6, 9, and so on. Right, and you think to yourself, okay, what do they have in common? What do they have in common? 2z intersect 3z. Let me see, let's circle stuff that's common. Now, probably for your purposes, you're going to want to write out more of 2z and 3z to get a sense of what they have in common. But let's see, it's anything that, okay, let's see. All right, so you'll see that this is multiples of 6. Right, so really, this is 6z. Now, I don't want to give it to you too much, but there is a little trick in here. It's not as easy as saying, okay, just multiply them together. If you multiply them together, you'll get the wrong answer. If you multiply all the numbers together, if you multiply 5 times 4 times 3 times 2 times 1, you'll be off by a factor of some number. I won't tell you what that is. So there's something to think about here. So now what you want to do is you want to reduce this down to something z and then put that together with 5z.